Okay, let's take a look at this page in your workbook. You might be looking at this and thinking, oh my gosh, Mrs. Taylor, we did this in like 4th or 5th grade, and you're right, but I just want to review it because we looked at finding the least common multiple, or eventually least common denominator of numbers back then, but now we need to look at it in terms of things that might have numbers and variables, things that might be monomials, things that might be binomials. And so I want to refresh your memory on how we did it here, because it does translate pretty nicely as we go from numerical least common multiples into polynomial least common multiples. All right, because eventually we're going to start adding and subtracting, multiplying, dividing fractions that have polynomial numerators and denominators. All right, so let's take a look at 12 and 15. Now, if you remember back in 4th or 5th grade when we did it, what we did was we found the prime factorization. And so in this case, we would say 12, well, that breaks down to 4 times 3. Again, you might be thinking of something else. It shouldn't matter. Eventually, we'll get to the same thing. 4 is not a prime, so that's 2 times 2, but 3 is. So we end up with a prime factorization of 12 as being 2 times 2 times 3. I could also write that as 2 squared times 3. All right, then we do the same thing with the 15, and we say that that is 3 times 5. Both of them are already prime, so I'm going to circle that. So we would say that the prime factorization of 15 is 3 times 5. All right, everybody good? Okay, now what we're going to do is we're going to take those prime factorizations and we're going to line them up on top of each other. So it will work for either way, whether we write it every single one out or write it as exponents. I'll do one of each type so that you can see. But this would be 2 times 2 times 3. That's the 12. And then the 15, now, if you remember, I liked to do this so that the factors that they share lined up. So instead of doing 3 and 5 right here, I'm going to do the 3 here and the 5 right here. And then what we said for the least common multiple was let's go through and circle all the ones that they have in common, and we'll bring them down. All right, so here we're going to bring down this 3 that they share in common, and then we'll bring down everything else that they have that's not in common. And the least common multiple is going to be their product. So this is 2 times 2 times 3. That gives us 12 times 5 gives us 60. So the least common multiple, or again, least common denominator, depending on whether we're working with fractions or not, is 60. Let me do this again, but let me do it with the written as 2 squared times 3. So for 12, it's 2 squared times 3. And for 15, it's 3 times 5. So now I would say, let's circle whatever they have in common. That's the 3. And bring down everything else. That's 2 squared times 3 times 5, and still we'll get the same thing of 60. All right, let's do number 7. I'm just going to go sideways here because I'm trying to pick some interesting ones. All right, so for 36, we're going to say that that's 6 times 6. Again, maybe you chose 3 times 12 or 4 times 9. It doesn't matter. Here I'll get 2 times 3, and here I'll get 2 times 3. They're all prime. And so we would say 36 is either 2 times 2 times 3 times 3. If you remember, we wrote them in order, so don't do 2 times 3 times 2 times 3. We group all the same ones together. And then here we could also call this 2 squared times 3 squared. All right, for 80, I'm going to go with 8 and 10. 8 breaks down into 2 times 4. 10 breaks down into 2 times 5. The 2 is prime, this 2 is prime, this 5 is prime, and then 4 I'm going to break down into 2 times 2. So for 80, I would write that as 1, 2, 3, 4 2s, so 2 times 2 times 2 times 2 times 5, or I could write that as 2 to the 4th times 5. Now, when I go to find the LCD, what I have to do is line them up. So I'm going to use the non-exponential one. So for 36, that would be 2 times 2 times 3 times 3. Actually, I'm going to leave a little bit of space here in anticipation for what's coming up. I did not leave myself enough room here. So 2 times 2 space times 3 times 3. For 80, it's 2 times 2 times 2 times 2 times 5. Again, that's not a critical step. I just like to do it. So we're going to circle everything that they have in common. So I have a 2 here, another 2 here, and then I'm going to bring down everything that they don't have in common. So I have another 2, another 2, another 3, another 3, and a 5. So all together, I end up with 2 times 2 is 4, times 2 is 8, times 2 is 16. And then I have 16 times 3 is 48. 48 times 3, I don't know. That's 4 carry the 2. I should have known that. That was 144. And then 144 times 5. 0 carry the 2. 2 carry the 2. That's 7. So the least common denominator, least common multiple between 36 and 80 is 720. Dang, I wouldn't have guessed it was that big. All right, let me do that again with the exponents version, and I'm going to do it up top here because I'm completely out of space. But let's say instead I wrote that the factorization of 36 was 2 to the 4th times 5, and then for 80, nope, I'm totally making that up, 2 to the 4th times 3 squared, and then for 80 it was, oh my goodness, my apologies, 2 squared times 3 squared. For 80, it was 2 to the 4th times 5. And again, I'm going to write this over here. Okay, so now when I bring them down, I'm going to say, oh, well, they definitely have a 2 in common, but what do I bring down, the 2 to the 2nd or the 2 to the 4th? Well, the part they have in common is 2 to the 2nd. But because I need to bring down even things that they don't have in common, I'm going to bring down the larger of them. So the 2 to the 2nd would be what they have in common. That other 2 to the 2nd is what they don't have in common. So altogether, I'm going to bring down a 2 to the 4th. Right here, it's not in common that they have the 3 squared. It's not in common that they have the 5. Right? So the interesting part here is what to do with the exponents. I take the larger of them because I count the common part and the uncommon part there and just bring it all down at once. All right? So in this case, again, we would get 720. So if you don't feel like writing out all of the factors like this, then you can write the exponent version and then just remember to take down the largest one because we need to make sure that it includes all factors. And so we would have to include the 2 to the 4th because if we just did 2 to the 2nd, that 2 to the 4th would be missing some of its factors in the least common multiple. All right, let's do, let me find another one. How about we do 45 and 70, problem 11. Actually, how about you do that one? So pause the video for just a minute, and I want you to do that, and then come back to me when you're done, and I will work through that, and you can make sure that you did it properly. Okay, so for 45, we've got, I'm going to do 15 times 3, and then this is 3 times 5. So my prime factorization is 3 squared times 5. For 70, it's 7 times 10. 7's a prime, 10 is not, that's 2 times 5. So we've got for 70, 2 times 5 times 7. And then I'm going to use the exponent form. It actually doesn't really make a difference in this case, but for 45, I would get 3 squared. Nope, I'm going to scooch it over just a little because I know I need to leave room for the 2 in the bottom there. So it's going to be 3 squared times 5. And then for 70, it's 2 times 5 times 7. So I bring down everything they have in common, which is just a 5. And then I bring down everything they don't have in common. So that's a 2, a 3 squared, and a 7. All right. So I already know that 3 squared times 5 is 45, all right, because I already factored that. And then the extra part is 14. So let me just do 45 times 14. Actually, you know what I'm going to do? I'm going to do the 45 times 2 and get 90. This is going to save me some time. And then 90 times that 7, which is 630. All right. So hopefully that was a good refresher for you, and you're going to be ready to move on to the next page, which is when we do finding the least common multiple of monomials. Okay, hopefully you're on page 122 now, because we need to start looking at how do I find the least common multiple of two monomials, right? So let's take number 1 here, and let's write them out here. So we've got 2xy, and then we've got a 4y. Before we do this, I'm going to break this down to its prime factors. So I'm going to write this not as 4y, but 2 squared times y, because the number part is not going to change when we find the least common multiple from what we just did regarding finding the least common multiple of two numbers. So if it's the coefficient, we'll just revert back to what we just did in the last video. Okay, so let's take a look at these. So essentially what we've got is 2 times x times y, and then 2 squared times y. And if I do what I did before, I'm going to write this as 2 times x times y, and I'm going to write this as 2 squared times y. And first thing I'm going to do is bring down everything they have in common, so that's a y squared. But again, when we use that exponential form like we did before, we say, well, what they have in common is they both have 1, 2. Right? This one happens to have more than 1, 2, but they both have exactly 1, 2 in common. But because we're also going to bring down the things that they don't have in common, we're just going to right now bring down the 2 squared. All right, we'll bring down the larger of the 2. So we're going to bring down a 2 squared. Sorry, I drew the loop here but didn't bring it down. And then we'll bring down anything they don't have in common. So this is going to be x. So our least common multiple is going to include the 2 squared, the x, and the y. And so this is going to end up being 4xy. So the least common multiple of these two monomials is going to be 4xy. All right, let's take a look at this one. Suppose we have 3a cubed b squared c, and then we have, I'm going to put the 5, since I didn't leave room for it, I'm going to put the 5a squared b squared c squared. All right, so the first thing we do is we take down what they have in common. I'm going to choose the ones that are identical first. So they have a b squared in common. Then I look at these two, the a's, and I say, well, they have an a squared in common. This guy just happens to have extra. All right, but what they have in common, but then I'm going to, instead of saying, well, let me bring down the a squared, and then later having to bring down this extra a that this guy has, I'm just going to bring down the higher of the two right away. All right, so this takes care of bringing down the common and the uncommon at the same time. Same thing with here. The only thing that they have in common is a c, but because I also bring down what they don't have in common, I'm just going to do that all at once and bring down a c squared. Right, so again, in each case, I bring down the highest of the two exponents, or in some cases, maybe we'll have 3 or 4 that we have to do this for, but you bring down the highest of them. And then I'm going to do the same thing with the numbers that we did in the last part, which is I'm just going to bring down whatever they don't have in common here because they do have nothing in common. All right, so our least common multiple, or least common denominator, whatever we're using this for, is going to include a 5, a 3, an a cubed, a b squared, and a c squared. That's going to turn into 15, the 3 times the 5, and then a cubed, b squared, c squared. All right, let's skip down to, let's say, number, actually they're not even numbered. Let's look down at this fourth problem. So we've got 4 x to the 7th, but again, remember, I'm going to write it as its prime factorization form. So 4 is the same thing as 2 squared, and then we have an x to the 7th, 8, again, you can do this on the side. I just happen to know it's 2 cubed. And then this is x squared. So I'm going to go through, and in each case I'm going to choose the higher of the, that factor's, would take the factor with the higher exponent because that accounts for the common and the uncommon all at once. So here we're going to bring down a 2 cubed. And in the x to the 7th and the x squared, we're going to choose the x to the 7th. Right? And so in this case, the least common multiple would be 8x to the 7th. All right, let's do one more. Let's say we look at the very last one. All right, so here I'm going to look at this as 2 times g times h. 6 I'm going to write as 2 times 3. Again, I screwed that up. Let me write it as 3 times 2 times g times h to the 9th. I'm going to bring down whatever numerical factors they have in common. That's a 2. And then they have a g in common. Both g's are to the first power, so I'll just bring down a g. And then when I look at the h's, I'm going to bring down the higher one because I want to include everything they have in common and everything they don't have in common. And then I'm going to bring down this 3. All right, so all told, we end up with 6 times g times h to the 9th. All right, I'm going to let you do some of these on your own, and you can check the answer key to see how you did. Okay, let's take one final look at least common multiples. We went from finding the least common multiples of just 2 numbers to finding the least common multiple of 2 monomials. And now we're going to do least common multiple of 2 polynomials. Right? Now the first thing I want you to notice is that when we do these, we have to find the prime factorization of each of the polynomials. Right? And what that means is that in a lot of these cases, we're going to have to factor one or more of the polynomials that they give us. If you look at this, this is already in its prime factorization form. Right? This would have said that we had some polynomial that factored into z minus 3 times z minus 3 times z minus 3. I can't factor z minus 3 anymore, so this polynomial right there, or this binomial, is already a prime factor. Right? I can't do GCF with it. It's not difference of squares. Clearly it's not a trinomial or grouping. So that is factored completely. When it's got the cubed on it already, it means it had 3 of the same factors, just like we would take 8 and turn it into 2 cubed. Right? 2 is prime. So when I write it as 2 cubed, this is its prime factorization. All right? So that is already in prime factorization form. But this is not, because we can factor it more. Right? So we're going to write this, it's a difference of squares, so we're going to do this as z minus 3, z plus 3. All right, so let's work over here. So I'm trying to find out what the least common multiple of these 2 polynomials are. So I'm going to write this as, the first one is z minus 3 cubed, and underneath it I'm going to put this z minus 3 that they share, and I'm going to put this z plus 3. So again, remember when we're trying to find out what the least common multiple is, we look at things that they have in common. So they both have factors of z minus 3. The only thing they have in common is 1 z minus 3. All right, that just has 1. This guy has extras, but that's okay. So they have a z minus 3 in common, but because we're going to have to bring down all the uncommon things too, we're just going to do that all at once and bring down the greater of the 2. So we're going to bring down the z minus 3 cubed. And then we have to bring down everything that they have that's not common. So this is z plus 3. And that is the least common multiple. All right? So it looks kind of weird that we have z minus 3 cubed and z plus 3. And maybe it feels unsatisfying because you feel like you should multiply it out. But I promise you, it's less work to leave it multiplied out, and it's more helpful. So just leave it exactly like that. All right, let's look at the second one. Right, so we've got something that is in prime factored form already. Again, I can't factor either of the 2 factors. There's no GCF in either of them. It's not difference of squares. They're not trinomials. They're not grouping. So that's already factored in prime factorization form. But this is not. Right? It's a easy general trinomial. So what I'm looking for is 2 things that multiply to 11 that add to 12. Hopefully these have gotten easy enough for you that you can say, oh, that's 11 and 1. So this is x plus 11, x plus 1, and then this is x plus 1 and x minus 3. So just as before, I'm going to write the two factors. So this is x plus 11, x plus 1, and then I'm going to line them up underneath. So this is x plus 1 and x minus 3. I look for anything they have in common. These both have a single x plus 1. There's no extras in either of them, so I'm just going to bring this straight down without much thought. And then I look at the other remaining factors that they have that are not in common, and I'm just going to bring them down. All right, so the least common multiple, again, later as we put these as denominators and fractions, we'll call it the least common denominator. But for right now, the least common multiple is x plus 11, x plus 1, x minus 3. Oops. All right, let's do one more. Let's do this one right here. And then I'm going to leave these two for you to do on your own. All right, so in this one, already in prime factorization form. All right, because I can't factor any of these binomials any further. So I'm going to write this as x minus 7 to the 4th. X plus 2. Then I'm going to write this x minus 7 first, so it goes under here, x minus 7 squared, and then I'll write the x minus 1 over here. I look at these two that they have a common factor there, and again, the x minus 7 squared is what they have in common, but I'm going to bring this one down because that takes care of the common and uncommon all at once. And then I'll bring this down, because it's uncommon, and this is uncommon. So this would be their prime factorization. This would be their least common multiple. X minus 7, whoops. X minus 7 to the 4th, x plus 2, x minus 1. All right? You're going to do the last two on your own, and you're going to use the answer key to check it. Be careful with your factorization of this. All right, you're going to factor it once, and then you'll find you can factor it again. All right, so don't just stop after the first factorization. There's more that you can do. Okay, good luck.